Good morning. Today we're going to be working on the density determination lab. So if you go on your notebook, your class notebook, you'll find a copy of this, and we're going to do this together. So I'll take a series of measurements, and you will write the measurements down. So the first thing, what is the purpose of this lab? In this lab, we're going to be taking a clear liquid, and you have to use density to determine what that liquid is. So for example, if I were going to give you this and say, here, drink this, it's water, but you know I'm trying to poison you, you want to do a density to determine that it's not, determine if it actually is in fact water. Okay? So the first step then for this density lab is we are going to determine the density of an irregular object. The density of it, just to test out that the equipment is working, and just to kind of familiarize yourself again with density. We're going to take an irregular object. In this case, we're going to take a rock. So on your letter for table A, you will write down E. So E is the letter for this rock, and we're going to take the mass of the rock. So when I take the mass of the rock is 10.19. So I record right there 10.19. The second step is we have to take the volume of the rock. In order to take the volume, we are going to do a displacement. So I fill the graduated cylinder with 20 milliliters of water, and I'm going to simply drop the rock in. Now when I drop the rock in, I don't want to drop it this way and have it plunk and all the water comes shooting out. So I'm just going to slide it down gently so I don't lose any water. And then I'm going to record the value. So the volume of that rock is now 24, or the volume of the liquid is reading 24. So we started at 20, and now it says 24. So therefore, the volume of the rock was 4. So now I would simply calculate the density of this. So remember, density equals mass over volume. And in this case, for the mass, we had a 10.19 grams, and we had 4 milliliters. So when you punch that into the calculator, what do you get? So take a moment to calculate that. And when I did the calculation, I got 2.55 grams per milliliter. So that is the density of that irregular object. Now the second step, table B, is the unknown liquid. So for the unknown liquid, we're going to take a series of measurements. So we actually want to repeat the steps on this. We're going to do it 6 times. We want to take multiple, want to do this multiple trials, so this way we can actually calculate an average to sort of lessen our chance of having an error. So the first thing we're going to do is we're going to be using 2 graduated cylinders. We have a small one that goes to 10. So when we're calculating the volume of 5 and 10, we'll use the small graduated cylinder. And then when we get to 15 up to 30, we'll use the larger graduated cylinder. So I need to take the mass of these when they're empty. So, and just here on the side, you're going to jot this down, small graduated cylinder, and the mass of the small graduated cylinder is 37.88 grams. 37.88 grams. And for the large one, we've got 72.95 grams. So you're just going to make a note of that, jot it down over here. Now we're going to start filling our liquid. So I'm going to add 5 milliliters into the graduated cylinder. Okay. And I'm going to weigh that. Now when I weigh that, it comes out to 41.78. But remember, we have to subtract the weight of that graduated cylinder, which is 37.88 88 to get the actual mass of the liquid itself. And if you do that correctly, you should wind up with a 3.9 grams. That's the mass of just the liquid. Okay, so for each one of these steps, you're going to have to do this, subtract the weight of the glass to get the mass of just the liquid. All right, we'll go to the next one. We'll add 5 more to go to 10. So for this one, I have a 45.68, 45.68, and again, you have to do the calculation. Next, I'm going to go to 15, so now I have to go to the larger cylinder. So again, I go to 15. And this gives me 84.16, 84.16. And now here I have to subtract the weight of the largest cylinder. And remember, when you're reading the meniscus, reading the graduated cylinder, do you remember that thing we taught you, the meniscus, right? So when I'm looking at the liquid, I'm measuring right at that curve, which is the meniscus, and trying to do that as accurately as possible. Okay, the next one, we're up at 20. All right. And for 20, I got 88.15. So 88.15, that's for 20. For 25, I have 92.34, 34 grams. And then finally, for 30. And for 30, I have 95.96, 95.96. Now, once I have all these values, I can go ahead and calculate the density. So if we go back to number 1, my first question, the first one. So this was for 5. This was for 5 milliliters here, right? And I do the math there. I get a 3.9 grams, right? So that was the mass of 5 milliliters of this liquid. So now to do the density, right? Density equals the mass, 3.9 over the volume, which was 5 milliliters. 3.9 grams over 5 milliliters. And if I do the calculation, I get 0.78, and this is grams per milliliter, right? So that would be my density for the first one. So now you're going to go ahead and calculate the densities for each one of these. When you calculate the density for each one of these, make sure you go to 4 decimal points, no more than 4. So in this case, when we put in the calculator, we only had 2 decimal places. But go for a maximum of 4 decimal places. Once you have all of the densities here, then what you need to do is take an average to get the density. Remember, the reason we did multiple trials is we're trying to get a higher degree of accuracy. So we do multiple trials. Then I'm going to take my 6 densities, add them together, and divide by 6 to get my average. Once I have my average density, and I'm going to write it out to 4 decimal places, Once I have my average density, then I'm going to go to the back and I'm going to match it against this chart, and I'm going to see which liquid it is. So by using the density, I can actually figure out which one of these liquids it is. Okay, so these densities back here are to 4 decimal places, so that's why I'm telling you, try and go to 4 decimal places on these. So once you identify your liquid, you'll write it up here and then calculate these other questions. Okay, so take some time to do this. Use these numbers. So you got all your measurements now. All you need to do is make all your calculations. Okay, if you have any questions, please send me a message through Teams. Have a great day.